Okay, we can start. Yeah, then we start in 3, 2, 1. Hello, everyone. Welcome to this Lectures at Home session. Today we have here two speakers from Motius. They can introduce themselves in a second. As usual, if you have any questions, you can write them in the chat, or depending on the speakers, perhaps you can also interrupt and talk directly. Okay, then I will give the stage to Motius. Thanks for being here.
Okay. Yep. Thanks, Sandro. One. I guess I don't know all of you, but when I saw in the chat, it looked like we have a very multicultural group. So, and also, it's also like I see all the genders there. So I think it's a good start. Just before we start, I'm announcing this that as soon as you have some questions, feel free to write them in the chat. Me and Furqan, we will be presenting, but the guy who is not presenting, he will be looking into the chat to see if there are any questions. And we will try to answer as many as possible, and also see how much time allows us. Okay, so let's begin. Just an introduction to this topic. What we are going to talk about today is basically how do we do the resource allocation in Kubernetes, and what are the pitfalls of this resource allocation. So sometimes it looks like the resources are getting allocated properly, but in reality, they are very different. So we will try to go a bit more into depth and figure out what can be the normal pitfalls. As you can see from the topic, this presentation is a bit more in detail in Kubernetes, but since we don't know what is the level of knowledge of everyone about this topic, we'll try to still give a small introduction to get everyone familiar with the topic and with the basic terminologies before going into detail. But the second half, I would say, of this lecture would be very detailed into Kubernetes. But we'll try to make it as interesting as possible. So let's start. This is the basic agenda that we have today. So we'll just start with a small introduction about us. We'll move on to a small introduction for Kubernetes. We'll try to also define a little bit or describe a little bit how the resource allocation happens in Kubernetes. And then we will move into the interesting part, which will be going a bit deeper into how to test the resource allocation, what can be a possible production use case, and then also try to give you a live demo, what can happen and how can we debug if our application is basically failing. As I said already, a Q&A is, we will have some time in the presentation for Q&A, but I would suggest that as soon as someone has a question, you can write in the chat, so we can incorporate that during the time when you have this question. So it will be better in that case. And at the end, to finish it up, we'll provide some learnings, mostly related to the topic. Cool. So before starting into the topic, I'll just quickly give a small introduction about Motius, who we are. So Motius is a tech company in Munich. Technically, we are a consulting company, but that is not completely true. We are more of an innovation company. What I mean with that is we have different clusters. We are working on projects for all the different clusters, like all the different technologies, informatics, mechanical, electrical, machine learning, and multiple others. And we also have a very fluid structure. We have a core team, and we also have a talent pool. Basically, in talent pool, we have a lot of working students and freelancers, and also a lot of different people who are interested in working with us, and they can choose in which projects they want to work with us. And it is also not possible to work with us part-time. We also get a lot of people who join us in the talent pool and then switch to becoming a core member. For example, me and Furqan, we both are examples of this case. So we both studies in TU München. We both did like our masters in informatics, and during our masters we were working as working students in Motius, and then after our studies we switched into the core team. I chose a role uh, more into management because I was more interested in that. I was also basically a developer before, but due to my interest, I chose a role in management. And Furqan still stayed in the development itself, and he is now a tech specialist. And he also works in a lot of different technologies, which is an example of the fluid structure that we have. So roles are also not fixed; the roles can be changed. Moving forward, so just a quick introduction. Me, I'm Sahil. As I told you, I am from India, and I have done my master's from mentioned. I have a background in development and also DevOps, but right now I am a project owner, which is basically figuring out how to make a project work and how to deliver a project. Furqan, if you want to give a quick introduction, now is the time.
Sure. Hi, guys. I'm Furqan. I'm a technical specialist at Motius. I've been working here for about 2 years. Like Sahil said, I joined as a student and then stayed for the long journey because it's been pretty fun here so far. I started my work as a backend engineer, but as I've worked more here, I've transitioned into doing some front-end work as well as some infrastructure-related work, which is where this Kubernetes topic comes from. And I'm from Pakistan. So you have an Indian and a Pakistani doing the presentation, but we're not going to talk about cricket. We're going to talk about Kubernetes. That's me. Let's go on, Sahil.
Thank you. So moving forward. Okay, before we start, we just want to judge basically what is the level of knowledge that everyone has. So it's just a quick survey, and we will just use the chat for this. We won't use any other tool. So basically, just how much do you know about Kubernetes? So you have three options. Basically, you have never heard about it, you know the basics, and third option is like you have used it. So everyone, please, I would request you to just write one of these options. For example, option 1, 2, 3, whatever you feel your level of knowledge about Kubernetes is. And let's give 2 minutes to everyone. You can write. 3, 3, 2, 1, 2, 2.
So in the YouTube chat, we have also one option 3 and one option 2.
Nice. It looks like we have a wide variety of knowledgeable people. Yep. But it's a good thing we structured this in the way we did, because we're also going to talk about a wide variety, a wide level of things in this talk today. We're going to start off with the basics, and then we're going to go deeper. Yep. I think it should be exciting.
Sure. So I think majority, or I would say like we have mostly people in option 2, then followed by option 1, and then option 3. Yeah, that looks good. Yeah, it's good that it's not all one. So we already have a good start, I would say. Okay, let's continue. Okay, yeah. So as I already told, like what is it about? This presentation is about resource allocation in Kubernetes. It is not a Kubernetes basics lecture, but although to include everyone in the presentation and in the lecture, we will still give a small introduction for Kubernetes. Yeah, let's start with that. So starting with a very basic journey of containers. So I hope everyone knows what a container is. So right now is I hope like everyone knows. So what is a basic journey of containers? Like why did we need containers and why were they they were invented? So like people say that a necessity is the biggest need for invention. So it was required. That is why they were invented. So I will just take a very basic case of a web development application in which we have an application server, we have a database, we have a file system, we have, yeah, let's say a logger. So and so we can see that this example already has 4 different applications that need to be run. Traditionally, what used to happen is we have a physical system at one location, which is connected to the internet via networking, and we would run these applications directly on the physical system. So, for example, if you have a MacBook, and if you install Microsoft Teams on MacBook, so this is an example of a traditional deployment where you are deploying directly on the hardware itself. What were the disadvantage of this? So one of the main disadvantages can be that the resources of the hardware can get wasted. Why? Because our application cannot take or cannot utilize all the resources of this hardware system. And the second disadvantage is that it is very hard to share this system with different, for example, different organizations or different applications, because there is a security loophole here, because all the applications are directly running on the operating system. So every application has access to the file system, and this is bad for security. So there is no isolation between applications, hence there is no sharing possible of this hardware, which leads to a lot of resource wastage. How this was solved was by virtualization, where basically a hypervisor, it virtualizes the kernel of the hardware, and on top of this hypervisor, now we are able to install multiple operating systems. So basically we can install multiple virtual machines, and each virtual machine can have its own operating system. And on this operating system, we can have different applications. One of the advantages of this system is that all the virtual machines are completely isolated from each other. So this enabled us to share the same piece of hardware among different, let's say, applications or organizations who want to have an isolated deployment for themselves. One example of virtual machines is, I can say, for example, if you have heard of Amazon EC2 servers, so these are basically virtual machines deployed on a hardware system. And there is a possibility that if I create a virtual machine, I might be creating a same virtual machine on a system that if Furqan created a virtual machines via Amazon console. What were the disadvantages of this? Why we needed to invent more? Were that yes, we are able to share resources, but in the process of sharing resources, we are also wasting a lot of resources. Why? Because we are deploying multiple operating systems on the same hardware. And operating systems are usually very, very heavyweight, which needs a lot of resources in itself. Hence, the containers were invented, which are basically virtualizing the operating system itself. And on top of the operating system, we can have different containers which are isolated from each other, and each container can have an application deployed. So this helped like in sharing and also saving more resources. And containers are basically lightweight, they are portable, they are super scalable. So these have all the advantages that we have over virtual machines. One of the distinct advantages of containers over virtual machines is that, or let's say not virtual machines, but more another advantage that we have for containers is we can have an environmental consistency between the people who, let's say, of the same team who are developing a software. So for example, we have, let's say, a team of software developers sitting in Munich. One team is sitting in let's say US, and they are developing the same application. And they are working together in a Scrum process. How do we maintain that they are using the same environment for development, so they don't face these issues that on one person's local device the application is working, but on the other guy it's not working? We can do it via containers. So we can share containers among different people, and these containers will ensure that we have the same environment among different developers. So we have containers. So I guess like people have also heard about Docker. So Docker is a containerization platform which you can use to deploy containers. Why do we need Kubernetes? We can deploy containers easily by using Docker. Then why do we even need Kubernetes? So Kubernetes is more, I would say, like a manager. So for example, if in a production application we have to deploy 100 different type of containers, yes, we can deploy it via Docker, but it will be very messy. It will be a chaos. So we need another layer in between, which will help us manage these containers and reduce our manual work to manage them separately. This is why we need Kubernetes. So just I won't be going into Kubernetes components because there are way too many components. I would just touch very basic components. In this one, I think we will only touch pods. So pods is like a basic unit of Kubernetes. Pod, we can say that Kubernetes does not directly manage containers, but it manages pods. And what is a pod? A pod can be a logical group of containers. So for example, if we have an application server running, we can also have a logger running with the application server, which is logging all the logs to one file system. So these two containers can be logically grouped together into the application server pod. And then Kubernetes will manage this pod for us. So that is a very basic, what is a pod? It is like the basic unit in the Kubernetes terminology, and Kubernetes will manage pods. Nodes and cluster. So what is a node? A node can be considered of as a entity which has all the resources. So for example, we can say it is a physical device, it is a physical server. But we can also say that a virtual machine is a node, because virtual machine can have resources. So then in Kubernetes we will have a cluster of these nodes, and the resources among these nodes will be pooled together into this cluster, and then these resources will be shared. So node is like we can say like this is the entity where the pods will be deployed, and all the nodes have some resources which will be pooled into a cluster in Kubernetes. So for the reason of this presentation, we will only say that resources are CPU and memory. We are right now ignoring network, storage, and everything, because for this presentation we are just focusing on CPU and memory. So so a node has a CPU and a memory, and pods will consume CPU and memory. So these are the resources that we are concerned about. How do we allocate these resources? So basically there are two terminologies for allocating resources. There is a request and there are limits. Here you can see that there is a sample configuration file to deploy a pod in Kubernetes. And you can see that in this pod there are two different containers, and each of these containers are basically requesting some resources. Since we are pooling the resources together, we don't want to request exact amount of resources for each pod, because then it's very difficult to know. For example, if we have 10 nodes and then we have 15 different pods running on these nodes, to calculate exact amount of memory and CPU that these pods will consume, it's a very tedious process. So we basically give a range of how much resources that this pod can consume. So we will request an amount of for example, here we will request memory 64 megabytes, but we will say that at most if we need, we are still allowed to use 28 megabytes of memory. So this is a range. So we can use somewhere between 64 and 128. So 64 will be considered at the basic available, which will be always available to us if we need it. And at some points of time when there is not a lot of load on the system, we can also use 128 megabytes of memory. Yeah, so this is the basics, I would say, of resource allocation in Kubernetes. And I think we can check if we have any questions in the chat. No. So then I will give the control to Furqan, and he can take over and give us a production use case and also a live demo. Furqan?
Yep, I'm here. Thank you, Sahil. So that was an intro to Kubernetes for all of you guys who wrote one. To summarize, it's a bit of a magic technology that takes your Docker containers, your Docker images, and deploys them magically on a group of machines. And organizations are lately moving towards this trend where instead of having either separate machines and natively deploying your components there, or having virtual machines and messing with that sort of stuff, there's a lot of tooling required to have such a thing running in production. That's also one of the reasons that we are moving towards Kubernetes, because with Kubernetes, you just get one cluster and you have a pool of computers, nodes, as Sahil explained. You have a pool of nodes that is running on that cluster, and you could run a number of different applications on it. There's also the concept of namespacing, where you can separate your services into different namespaces, so you can have various different kinds of things running on one cluster. Just to give you an example, at Motius, we have for internal testing, for staging and development servers, we have our own Kubernetes cluster. That's about, that has like 10 or 12 different nodes, but it's running tens of different applications separately. They're staging servers for testing and all that kind of stuff. And it makes it super easy. So next slide, Sahil. Yeah, Sahil is doing the slides, so I'm going to be saying next slides a lot. Sorry about that. So now we're going to look at, okay, we have a pool of machines. We have this, we can make abstract containers and run them on machines. And a lot of companies, as I said, are adopting that. But at some point, people just accept the magic. And sometimes accepting the magic can cause problems. And that's what we're going to do here. We're going to demystify it. The inspiration for talking about this came directly from a project I was working on for Motius. A couple of months ago, I had this problem where I had an application that was running on Kubernetes, a bunch of different pods, and it was in a bunch of different namespaces. So it was a couple of different deployments, as I explained before, that you can do that. And the pods kept dying, and they were dying with an out-of-memory error. So just to recap on the resource limits that Sahil just mentioned, the maximum limits for a container that you add, if a container uses memory above that limit, then it's going to be killed by Kubernetes. It's going to be what they call, the terminology is evicted. So if you look at the logs for your pod, you'll get an error message that says pod was evicted due to memory pressure. So I had this pressure, my pods kept dying. And the pods were running basically some asynchronous services. If you guys are familiar with Celery, Celery is basically a task, asynchronous task queue. You can connect it to some sort of database, for example, Redis. You can send tasks in Redis, and Celery would process these tasks. So typically in a web server, if you have a web application, for example, a REST API, and you want to do computationally intensive tasks in there, you wouldn't do it inside the API itself because that would block the API call. So imagine there's an API call to send emails to thousands of different customers. If you're sending out those emails inside the API, then your HTTP request is going to be blocked as long as the backend is sending out those requests. So typically, for such a thing, you would abstract it away. You would put the sending of the email in a separate task queue. So the API would receive an action, say, send email to these 1,000 users, and it will send a task to Redis. The Celery worker would pick up the task from this queue and process it asynchronously outside of the context of the HTTP request. So I had something like this running in different namespaces, and those pods kept dying. Naturally, I got a shell access to those pods. So as I'll explain before, the pods are just running containers inside them. Containers are just Docker containers, and you can SSH into them, basically. So I did that. I ran the command top to see what resources are being used, and it looked A-OK. There was plenty of free memory available, but I had no historical information, so I couldn't tell what the issue was, why there was memory pressure at times. And it took me a couple of months to find out what the exact issue was. Of course, during those months, I wasn't completely working on this. I gave up, and it's okay to give up. So in this talk, we're also going to give you life lessons. It's okay to give up sometimes and then come back with a fresh mind to a problem. That's what I did, and I found out these things, and this is what I'm sharing with you today. So in this live demo, I prepared a similar kind of scenario, and we're going to go through it together, and we're going to debug the problem together, and we're going to look at each and every number and demystify that magic that I talked about. So imagine here, pictured right, you have a namespace. Imagine you have a bunch of different namespaces, each running this exact setup that I defined. In this image, you see a Redis container, a Redis service, and another container with Celery workers running inside of it. So let's take it step by step. These things are labeled 1, 2, 3, and 4. So number 1 is a Celery worker. So this is a process running inside the container, which is taking the tasks and processing them. Number 2 is the container itself. So that's the Docker image, that is containing these workers. And then, as I'll explain before, it is contained in a pod. So this green color thing is the pod. So this thing I'm calling the task handler. It handles tasks. So as Sahil said, the pod could contain more than one containers as well. So you could couple together a bunch of different stuff. So in the web use case that I described, in the task handler pod, you could be running a task handler container and a backend container. But this is a simplified example just to extract the problematic parts out of it. So these are numbers 1, 2, and 3, the task handler itself. The big blue background is the namespace. Like I said, you could have multiple namespaces in a Kubernetes cluster, and this is one of them. Let's take a look at number 4. So the number 4 is also a pod, but this is the Redis pod. So basically, to run this task handler, we just need 2 things: a queue where we put the tasks and a worker which takes and processes these tasks. The Redis pod also contains a Redis container, and the container inside it contains the Redis database and the process running. And number 5 is the Redis service, which I'm going to explain in a while. The Redis service basically just allows other pods to connect to this Redis pod without routing through an external network. So the Kubernetes pods, when they're running inside a cluster, they have an internal Kubernetes network. So it's kind of like you can picture it as a subnet. So, and the services is, you can picture it as it's an analogy. So it's not the exactly what's happening, but the Redis service, you can imagine it as DNS. So it allows other pods to resolve the access to this pod. So we're going to go step by step throughout all of these things, look at the code, see what it is. As a lot of you said that you don't have a lot of experience with Kubernetes. So we're going to go slow through the step and explain every single part of this application in detail before we get to the big juicy part of introspection, So this is the first thing inside of this demo application, the Celery worker itself. So this is some Python code. As you can see, I create a Celery instance. I give it the link to the broker. So the task queue, the actual database is called the broker. Celery, you can connect it to Redis or RabbitMQ or any kind of queue, basically. Here I'm connecting it to Redis. And this thing you see, Redis-service, that's the name of the service itself. So the big yellow box, Redis service, I just refer to the Redis service by name, and Kubernetes will do the job of resolving it to an actual pod. So this is the aforementioned magic that I talked about. And then here I have 3 tasks. So I gave you the email example. You want to send emails. Of course, this task obviously doesn't do anything actually, because it doesn't know how to. Similar examples include resizing images. So if, for example, you have an API that takes a user's profile picture, and the user uploads it, and you want to convert it to a bunch of different sizes for using it throughout your front end. That kind of thing you will also do asynchronously. So you could have a task for that. Log rotation, you could have a task for that. So, excuse me, you have a Celery worker with some tasks. Let's go to step 2. The Celery worker is running inside a container. How do you build a container? This snippet you see on the left, this is a Docker file. So if you've already worked with Docker before, you know that Docker file is the specification for a Docker image. It just tells you how to create a Docker image. This also, people think it's very complicated, but it's not. Docker files are very simple, very readable. So here, I'm assuming also people don't have a lot of Docker file experience, so I'm gonna go step by step in this one as well. You have a base image. Basically, every Docker image is built on some other base image that someone else built. So I'm pulling Python 3.8. Buster is the Ubuntu version. So I'm pulling a Docker image that already has an Ubuntu inside of it, and it has Python 3.8 pre-installed. And I'm telling it the directory where everything happens is /task handler. Docker image will just create that directory. And I copy my files to that directory. So this Docker file would be running inside the folder that contains the rest of the code. So in the previous step, the Celery file that we saw, that's going to be contained in a xyz.python file, task_handler.python. It's going to get copied into the Docker image. And then I run pip install. If you work with Python, this is installing the dependencies. So basically for this exact example, you need 2 dependencies. You need to install the Celery module, and you need to install Redis. So that's the Redis client libraries for connecting to the database. And the last step is simply the command that's going to run when you run this Docker image by default. Well, when you run Docker images, you can also specify a custom command that you want to run. That's also possible, but it's nice to give a command inside the image itself. So this one, basically what it's telling is to start Python module Celery, and task_handler is the file name which contains the code for the Celery worker. And I give it the flag worker -C3. C is concurrency, 3 is the number of workers. So in the image to the right, you will see that there are 3 Celery workers running inside the container. That's how you do it. You can increase the number as well. So you can see we're building layers. Let's go to the next layer. Layer number 3 is the pod itself. So like Sahil explained before, a pod is the unit that runs inside Docker. And a pod can contain different Docker containers. So this snippet that you see, this is a configuration file. This is a YAML file. YAML is basically a data format similar to JSON, but different in the way that here indentations mean things and you don't need square brackets and that kind of stuff. So basically, it's just a configuration file. Writing these, there's a lot of stuff in here, right? So you go to, you look up for Docker reference, Docker file, Kubernetes configuration reference. You will have these reference files, and you can see which fields there are and what you want to type. This is, so here you can see that API version that tells which Kubernetes API version we are using. Kind is deployment. So this configuration file is for a deployment. Now it's confusing, I know, that we've been talking about pods and suddenly this is this pod description file is called a deployment file. That's because a deployment is one level above pods. Deployment could contain multiple pods. To simply put, there's a bunch of different levels in Kubernetes as well, and it's very confusing at times. But you just have to remember that it's just different layers. So a deployment, you can tell it to create a number of different pods. And here, if you follow along and see replicas 1, it says how many replicas you want to have. So if I set this to 2, in the picture to the right, you will see 2 task handler pods, both doing similar work, both running inside the deployment group. So this is how you can also do scaling and that kind of stuff. But here, for the purposes of this example, we only want to run 1 replica. And then there's a bunch of stuff like tags. So you can have labels on your pods, and that's what's in here. But the important stuff is labeled here below. So in the deployment, in the pod, we want to run a specific Docker image. And that's linked here in the third last row. As you can see, it's registry.motius.de/xyz/task handler latest. Now this is, in the previous step, we saw the Docker file. I built that Docker file and I uploaded it to a Docker registry. So in order to run Docker images inside a Kubernetes cluster, you need a registry. A registry is something that just stores your Docker images. And you could use Docker Hub, but if you upload to Docker Hub, your image is going to be public. If you want private images, I believe you need a paid account. So I just decided to upload it to Motius's Docker registry. And since it's the private registry, you need credentials to pull from the registry, and those credentials are provided here. Now you can see it's just a name. This is referring to a secret object. So there's everything in Kubernetes is called an object. A deployment is an object, a pod is an object, a secret is an object. Every object has a type. As you can see here, the type of this object is deployment. In the second row, it says kind deployment. So the kind for this pull secret is secret. I created that separately. It's easy to do. You just Google Docker pull secrets for Kubernetes, and you will find a lot of guys describing how to create such a thing, the secret. But for the purposes of this example, don't stress too much. Just think of it as a private registry. There are some access credentials, and we're pulling from that registry. So we've got half of the application ready. There's a question. I'm going to read it. In case you're using the Kubernetes service of the cloud provider you trust, then you can also use the Docker registry. Yes. Yes, that's correct. Thank you, Sandro. Yes, all the major cloud providers offer you their own registries. Azure has one, Google has container platform. So there's a lot of stuff. And this is this one that I'm using, it's GitLab. So I believe GitLab, the enterprise version also comes with a GitLab a Docker registry. I'm not sure if the community version comes with one, but yeah. many different options. It's not just Docker Hub or GitLab, it's many different options. So we got half of our application ready now. Let's move to the step 4, Redis. Now, Redis is much more simpler because we don't need to build the Redis application itself. We don't need to build the container. We already have a publicly built Docker image that we can use. And that we can pull from Docker Hub. Docker Hub is just a public repository for this kind of stuff. You have images for all kinds of stuff. You have Postgres, Redis, any kinds of database. A lot of the commonly used stuff, you will find pre-built images for that. So you don't need to build your own images unless it's your own application or unless it's your own, piece of code, or you want to massively customize it. So this is, again, a deployment configuration, just like the last step. It's saying one replica. We want to run one Redis pod. Redis can also run as a cluster, but that's a whole different topic. And we give it a label. The label will be used by the Redis service to know. Someone has a question, please go ahead. No, someone raised their hand. Okay, if you have a question, just chime in, please. Okay, so label, we're going to use it with the Redis service to route the network traffic to this pod. And here you can see image. It just says Redis there. So if you don't give a registry URL before the image name, it's assumed that it will be pulled from Docker Hub. And then the port 6379, that's the default Redis port. We expose it on the container. If we expose it in the container, it then allows it to use it in the Redis service, which then allows us to use the Redis service to connect to this port. Right, so let's go to the next step, the final step. This is the Redis service itself. The last line of this configuration, first of all, you will see that the kind of this configuration file, it's again a YAML file. You can describe all Kubernetes configuration through YAML, and that's the accepted standard at the moment. So the selector app Redis, this is the label that we gave to the Redis container in the previous step. And we select that, and then we map the ports. So this is how you create a service. Here's an extract of a code I read from Kubernetes documents today, and it's useful to understand. For a long time, I personally did not understand why we use services. It's all running in the same namespace, all in the same cluster. Why can't you just give the pod name and connect to it? So it says here that the reason is pods are ephemeral. They could live and die. They could be auto-scaled up, scaled down. The cluster could kill it and decide to move it on a different node, and then its IP will change. So the Redis service is a permanent resource that will always allow you to route to your deployments. So there we have it. This is the scenario that we're going to work with. This is the demo application that we're going to work with, and we're going to introspect it live to see what happens when you run it. Now, I know this is a lot of abstract mumbo jumbo, and sometimes it helps to look at real stuff in flesh. So I will share my screen and I will show you how this is all running and how this is all deployed. Right. So I got a Kubernetes cluster to demo this, and this is DigitalOcean. All major cloud providers allow you to manage Kubernetes cluster. You don't need to install it yourself. It's pretty complicated. So I got a Kubernetes cluster here. It has 6 virtual CPUs, 6 gigabytes of RAM, 180 gigabytes of hard disk. If I click on nodes, it will show me that there's a node pool. So there's a concept of node pools. You can have pools of different machines. So I have one node pool here, which has 3 different machines running. I call this pool party. I imagine all of you hysterically laughing behind your muted microphones. So you can add new node pools.
Furqan?
Yes?
Yeah, we have a question. So Do you have any experiences regarding running your own Kubernetes cluster locally with Minikube?
I have never done that, but you can do that. But I believe Minikube is just for development and playing around. I'm not sure if they recommend it for production use. I'm not sure. You'll have to look it up. I've heard of Minikube, but I've never really used it.
I think it's for development only.
Yeah.
Yeah,
but
that's what I.
Still the question holds.
Thanks for clarifying. That's my hunch was that.
But it's pretty handy, to be honest. Like to just test it out. Just it's very quick to deploy a cluster locally and just to test it out. Everything is pretty handy.
Yeah, if you want to.
Anyone starting in Kubernetes, it's pretty good.
Yeah, I think it's also helpful to get into Kubernetes and learn the stuff.
Definitely. If you want to practice this things that we learned here, definitely try it out on a Minikube.
And you don't need any cloud provider. You don't have any costs.
Yeah, exactly. But also with these modern cloud providers, if you run things, you get charged per hour. So I have been running this cluster for 48 hours now, and it cost me $2.79 so far. So if you want to just play around for a day, this is also a valid option. But Minikube, even better. Try it out. You will learn more deploying it by yourself. For production use cases for companies, yes, some companies do deploy their own cluster. At Motius, we use a tool called Rancher, which is a layer of cosmetics over top of Kubernetes. It just allows you to run your own Kubernetes cluster, and we do it. But we have a dedicated DevOps team. So this is, if any of you are here from the industry, this is what I would suggest. If you have a dedicated DevOps team that can manage a whole cluster, do it. But usually I would recommend for production use cases, just get a cloud provider. Right. So yeah, we have a cluster. We have 3 machines here which are running. What kind of machines are they? Hard to see, but I can show you from here. This is the one I used. 2 gigabytes of total RAM, 2 virtual CPUs, 1 gigabytes of usable RAM. We're going to look at this later. And a lot of cloud providers offer you their own metrics as well and their own insights. So you can get like CPU memory usage over time per node or aggregated for the whole cluster. This is different for every cloud provider. Everyone has their own tools. So yeah, but there are some open source tools as well, which we can use for all kinds of cloud providers. So, okay, this is, we have a cluster, nice. I will show you the code as well. Here's all of it. It's not a lot. This is task handler. This is the first file I showed you. This is the Celery task. The requirements.txt contains your dependencies. Then this is your Docker file. Like I said, Docker file and every other file lives in the same directory. So when I write this command, copy all files to this directory, it copies all of these files inside this directory in the Docker image. And then we have YAML files. So this is the one for task handler. And this is the one for Redis. So these are, this is a document separator. So I've got one YAML file with 2 documents inside of it. So you can see this is the deployment and this is the service. In the slides, these are shown separately. You can also have 2 different YAML files. Once you have a YAML file, you can connect to your cluster. Connecting to a cluster is different for all cloud providers, but once you are connected to your cluster, you can select it. I need to bring my terminal into view. Nice. And then there's a command line tool called kubectl. I would people use there's a UI as well that comes with Kubernetes, but I would strongly recommend learning the command line. There's a bit of a learning curve, but it pays off in the end. So we have kubectl. Let's see if we are connected to the cluster. and voila, we are. There are 3 different nodes inside of here. And if you want to, now we're here and we have all of these YAML configuration files. If you want to deploy something, you just give this file to kubectl and it will deploy it. Let's see namespaces. So if I do kubectl get namespaces, there's this namespace 1 in which I've already configured an existing system to show you guys. But let's create a new one, namespace 2. I forgot to tell it what to create. So I'm telling it create namespace with this name, and it created it. Sure enough, if we run the get namespace command, we'll see that there's a new namespace. Now I want to see what's running inside of this namespace. Hopefully nothing. And there are no pods inside of this namespace. Are there any services? We can check it with this get services. So I know it looks daunting at the moment to some people, I'm sure, the kubectl command line, but it's very intuitive. Once you get the hang of it, you wouldn't want to use a UI tool, and this gives you more power. So let's see how you deploy stuff. I'm going to deploy Redis first. So I take redis.yml. I say, in this given namespace, apply a configuration file, -f is a file with this name. And bam, there you have it. If I run get services, it says there's a Redis service running. If I say get pods, there's a Redis pod running. I can check the logs for this pod. So this is very basic stuff for those of you who say they never worked with Kubernetes. It's very intuitive. So you can see the logs of the container as well. You can also, like I said, you can get an SSH access to the pod, the container. You do it like this, exec. Exec takes a command and runs it inside this this container. And the command that I want to run is sh, which is shell. So now I have shell access to this container. If I run ps, it's not installed. I will just install htop because we're going to talk about it later anyways. If I run htop, it shows me that there are a bunch of different processes running for Redis. Pretty cool. And we're going to talk about htop in detail later on. So yeah, let's see what we have in namespace 1, the one that I already deployed. Namespace 1 has a Redis and a task handler pod running inside of them. So there you have it, a real cluster, everything running inside of it. There's a deployment.
Just a minute. Oh no.
So from the silence, I'm assuming everyone's either understanding everything or nothing. If you have questions, definitely feel free to ask. Go faster, and you say you already know this, also let me know. Right, so we've looked at the deployment. Let's go further, let's go forward. What else do we have?
It's a great pace.
All right, brilliant. for a lot of people, this is where they stop, and everything beyond this point is magic. But understanding how exactly and where exactly your resources come from will allow you to, first of all, make sure that you don't go under-resourced and your pods keep dying like me. If I can make one thing happen after today's talk, I hope no one goes through the same few months of torture that I went through thinking about this problem. Why can't I figure it out? But also over-resourcing. So it's also possible that you have too many nodes, too many resources, and you're not running enough stuff, and you want to reduce your costs, and that's also a possibility. So getting an understanding of this is important. Sometimes what also happens is that you have a lot of resources, they're all being used, but your performance is not good. What could happen is the parts of the application that are not critical could be utilizing more resources than the parts that are critical. So from my web server and Celery example, what could happen is that your Celery workers could exhaust all your CPU and your memory resources, and your REST API could start dying. And you want to avoid that. You ideally want the REST API to have most of the resources, and the background tasks could run a bit slower because they're not waiting in real time for anything. This can be achieved with the resource limits and the resource requests that Sagar mentioned in the beginning. So you could describe those resource limits on a pod level. So then you tell Kubernetes what your priorities are in terms of resources being allocated to pods. So you could have a limit that says if your Celery workers are using more than 90% of the CPU or more than 70% of the memory, then kill it. So understanding what's going on allows us to make decisions, basically, and that's the purpose of this. So let's go next and talk about understanding. So if you look back at this slide that Sahil. Sagar is another guy that works at Motius, by the way. Sahil showed in the beginning. A lot of people see there are containers running on a Kubernetes cluster and everything underneath is magic. So let's look at the magic. Let's go to the next slide. How do we monitor the available resources? So let's say first question is, I have 3 pods and I have a bunch of different namespaces. I want to see which node is running which pods so that I can understand better. You see this command at the top. It looks very scary, but it's actually just the same command that I ran before. If you ignore all the part in the middle, that's -o custom columns, blah, blah, blah. It's basically kubectl get pods minus all namespaces. So you could, when you saw me before, I was writing all those commands. I was giving it every command a -n namespace to qualify the command to a specific namespace. If you give minus all namespaces, it runs the command in all namespaces. And -o just formats the output of this command. So if you give -o custom columns, what I want to see here is the node name, which is the name of the physical machine where this pod is running, the name of the pod, and then the namespace. These are the 3 things I want to find out. So I had this, I also don't remember this command, and I don't want to type it out every time. I want to find the stuff. So I usually alias it in my zshelrc or bashrc. So in the screenshot below, you can see I've aliased it to kube all. Well, to be very honest, I renamed the alias just for this presentation. Usually the alias is a bit more profane because when I'm typing this command, I'm usually angry or frustrated trying to find a problem. So feel free to alias it to whatever level of profanity you're comfortable with while working. So when you run this command, you can see which nodes there are, which pods are running on which nodes. Great, that's step one. Now we're aware of all the pods that are running and all the nodes. Let's go to the next slide. But I have this question, and I'm sure a lot of you have these questions. Who are all these freeloaders? What is kubeproxy? What is core DNS? What is CLM? Why is this running on my cluster? I thought I paid DigitalOcean for my very own cluster, and this is not what I asked for. Every cloud provider, when you get a Kubernetes cluster, it comes preloaded with a lot of stuff. So, for example, the DO node agent is DigitalOcean node agent. DigitalOcean might want to run upgrades or collect data for metrics, as you saw in the dashboard. Core DNS, Cilium, to be very honest, I also don't have any idea, but a lot of these things are essential to the cluster itself, and they have to run. If you see the one in the very end is metrics server. Metrics server is very important. This is what I manually installed, and you can also install it on your cluster. Just look up how to install metrics server on Kubernetes. It's very simple stuff. I installed it manually. This is what's going to allow us to actually dig deeper into the resources. So yeah, you will have a bunch of freeloaders on your cluster. Usually they don't take a lot of resources, or the resources they do take. If you have a big enough application to justify using Kubernetes, these overheads then are very small. But if your application is a very, very small static front end, static website, nothing complicated, these resources are going to be these extra stuff is going to be taking a lot of more your resources than your own applications. So be aware of the trade-offs as well. When you get a Kubernetes cluster, you don't get all the resources you paid for. Let's go to the next slide. So the freeloaders is the magic. It's part of the magic. So you saw in the diagram before, you give your containers, everything runs seamlessly. You have services, you can connect to them. That's a lot of magic in a cluster, and these things are a part of it. So how do we monitor available resources? So when I had this problem that my pods were dying due to an out-of-memory error, my first instinct was to just jump into the container which was running it and see what the actual memory usage was. So I got a shell access, the exact command that I showed you before, just like how I just ran htop now. I ran it back then, and I thought, let's see what the available memory is. And let's go to the next slide. There's a screenshot there that shows what I saw. This is a screenshot from this demo example that we see. So I would go into my pod and I would run htop, and at the top, there's a memory column. It shows how much memory is used and how much is total available. It says 1.95 gigabytes is the total available memory, and 575 megabytes is the used memory at the moment. These colors, green, blue, and yellow, they mean a bunch of different things. Green is, I believe, the currently actively used memory, and yellow is, I think it's the virtual memory. I'm not sure. But the good thing about htop is once you run it, you just have to press one button, H, for help, and it will show you a very nice help document, which tells you what these colors mean, which tells you how you can change the processes being displayed here, how you can sort them, that kind of stuff. This is basically just the task manager that you get on Windows or the activity monitor that you get in a Mac. This is the same thing, just in a command line. And here you can see there's a bunch of processes running. You see that there are four actually celery processes running, whereas we actually gave it a concurrency value of 3. Actually, one of these processes is a parent of the other 3. So the actual number of workers running is 3, but the root command that you start the process with is also running. It's not doing any actual work because it just spawned the processes and then it's waiting there. So you also see that there. You can figure that out with the tree view. So htop comes with a tree view. If you press the button key, it will sort all the processes into a tree view. So then you would see that, oh, 3 of the Python processes are actually children of the first one. And there's a bunch of different columns. VIRT, RES, and SHR, they actually show you the memory consumption. RES is the reserved memory. So that's the current memory for that process that is physically in the RAM. Whereas the virtual memory could be stored as into virtual memory pages on the hard drive actually. So that's memory that's swapped out. So if I want to see the actual memory usage, I will look at the RES column. And these values are in bytes. Did someone want to say something? No, okay. These values are in bytes. So for example, this 33568 is 33 kilobytes. So if I sum up these numbers, this doesn't get anywhere close to 575 megabytes. So there's obviously something wrong here. Let's go to the next slide. Yeah, so this doesn't add up. We're seeing that the used memory is 575 megabytes, but if we actually count the reserve memory for all the processes, it's not 575. And if we remember from we just looked at the dashboard for DigitalOcean, we saw that the nodes that we got have a total of 2 gigabytes of memory. So this number that we're seeing here is actually the total memory and the memory usage for the node, the physical machine that this container is running on. So if you run htop in a Docker container, don't expect to see its actual resources. The listed processes and the resource usage per process is correct. Yes, Dominic, you're allowed to ask questions, of course. Would you scale Postgres using Kubernetes? Will that run on the Kubernetes master? Should Kubernetes master run on a server on its own? Okay. Postgres, you could definitely scale applications using Kubernetes. Of course, I don't think Postgres can run in a cluster mode. I don't think Postgres has any distributed capabilities. So if you're running some software that only has vertical scaling capabilities, then Kubernetes is not going to be of any help. You just need a bigger machine. So for Postgres, it's not going to work. But if you're using MongoDB, MongoDB can work in a cluster. What you can do is put MongoDB inside of a deployment. If you remember deployments from previous that I mentioned, you put MongoDB inside of a deployment and you set the number of replicas. It will then it will provide horizontal scaling. So with compatible applications, definitely this is how you do it. You put the application inside of a deployment and you configure the replica sets, basically. All right, so yeah, this doesn't show you the total stats are not correct. The per process stats are correct. And the reason is has to do very deep in Linux, but basically in Linux, if you run the free command or top or htop, it will all report the incorrect statistics because it pulls the statistics from a file. It's, I believe, /sys/proc/free memory, and that refers to the node's resources actually. So we need something else that will tell us the resource usage of a pod so that we can have a better idea. For that, you have kubectl top. Now, if you remember the metrics server that I mentioned before, that was one of the freeloaders, which I actually installed. That enables you to run these commands kubectl top pods or kubectl top nodes, and that will give you the resources of pods and nodes itself. Here you see the example. So if I see Nymsys1 top pods, it will show me task handler is actually taking 92 megabytes of memory. I believe in the previous screenshot in HTOP, it wasn't bytes of memory, it was kilobytes. Yeah, I think I have to correct myself. And then this would make sense because if you sum up the numbers from before, it will add up close to this number. So this is reporting the total correct sum. And if similarly, if you run kubectl top nodes, it's gonna show you all the different nodes, which percentage of the CPU you're using, which percent of memory you're using. In CPU, you see this 68M, 56M. This notation I didn't understand in the beginning. It's just M stands for milli CPUs. So if you imagine one CPU core is 1,000 milli CPUs, each node that I've got for this cluster has 2 virtual CPUs. So that means each node has a capacity of 2,000 milli CPUs. And this is how Kubernetes reports usage to you. And this is how you set resource limits as well. In the resource limits configuration that Sahil showed you in the beginning, you could see also that CPU cores, CPU limits were defined with an M in terms of milli CPUs. So here we see that Redis and the task handlers are using 26, 92 MB of memory. But somehow all nodes have greater than 50% of the memory allocated. So we got 3 nodes of 2 gigabytes of memory each. So in this talk, we're focusing on the memory example, but you can just as well apply this to CPU cores. The reason it's easier to do with memory is I just run an application and the memory stays constant if I don't do anything else, whereas to do it for CPU, I would have to constantly run some process and these numbers would change all the time. So it's a bit difficult to catch that kind of stuff. With memory, it's easier, but it's the same concept. And we can see that nodes already have more than 50% of their memory allocated already. What else is running on these nodes is the rest is magic. This is the exact point that I found myself with that problem that I was having. So I ran top pods and I understood, okay, this is the actual usage of my pods and they're hitting the memory limit of my nodes. So I checked the capacity of my nodes and I realized, hey, the nodes definitely are overloaded. All of them in my use case were using more than 90% of the memory. And I found out 2 things. One is there's a bunch of extra stuff running there. And the second one we're going to find together. So let's go next. So like I said, there's a question from YouTube. I think you can replicate any database, but you'll need some kind of proxy and some replication mechanisms. Okay, if yeah, I'm not sure. I'm really not sure about Postgres if it can run in that configuration. But if you have experience doing that, definitely. But like I said, it depends on the software that you want to scale. What Kubernetes allows you to do is run multiple versions of the same container. What happens inside the container is up to the application to coordinate. So if when I gave the Mongo example, with Mongo, you could run different replicas and you could pass them environment variables. So with those, you could tell, hey, this is the master, these are the slaves. So to all your replicas, you could also pass different environment variables. And that's so it's up to the application itself to support the horizontal scaling. So if you can horizontally scale Postgres servers on physical machines, so if you can run multiple instances, then you can run them on Kubernetes as well. And if you can't, then Kubernetes is not going to add any magic that makes an application horizontally scalable. That's, of course, the application logic itself. Right. So in this use case that we have, accounting for magic. What else? What is this magic? What's the magic code? Where is it running? Why is my node using more than 50% of the memory? So I ran this command, this scary looking command, but we are going to break it down to understand what this command is doing. It's kubectl get pods minus o wide minus a. Minus o wide gives you a lot of different columns as an output. And I actually found this out today while preparing for this. So actually the alias that you saw before, you could replace it with this minus o wide. It gives you a similar level of information. But with that alias, you can customize the columns that you get in the output. So I get, and minus a is also a shorthand for all namespaces, the flag I told you guys about before. So if you run kubectl get pods minus o wide a, it gives you all the pods and it gives you the information of which node it's running on. Then I ran grep. So this node pool party 8nf7p is the one where my Celery container is running. So I want to see what else is running on that node because my container is only taking up 90 megabytes of RAM. So I grab the output. So it filters out only the nodes running, only the pods running on that node. And then I use AWK to extract two different columns from the output, 1 and 2, which are basically the namespace and the pod name itself. And then I use xargs to pass those extracted columns as arguments to this command, kubectl top pod, this command we just learned. So kubectl top pods minus n, it takes the namespace and the pod from previous step. So basically then here you see a summary. The output of this command is a summary of all the pods that are running on this specific node. Node is the physical machine. So all the pods that are running on this physical machine and how much resources they're consuming. And this gives us a better number. So now you can see that this Cilium thing is using 136 megabytes. To be honest, I still don't know what it is. I will have to look it up after this because it's very interesting that it takes 136 megabytes of your 2 gigabytes total. And then some DigitalOcean worker, DO in every pod name refers to DigitalOcean. And then in the end is Redis and task handler, which is our code that's running. So if you sum up these numbers, this comes pretty close to the actual numbers that are reported by kubectl top nodes. So this specific node that we're talking about, it shows 902 megabytes of memory used. 902 megabytes of memory used, right? And if you sum up all of these, it comes relatively closer to this, but not exactly as well. So there's still something missing. There is still some more magic. So let's go to the next slide. And this is the second thing that I found out. So the first thing I found out is that my nodes are actually running a lot of stuff. And there's a lot of stuff, and also with namespaces. So like I said, my application was running different versions in different namespaces. So with different namespaces, it's easy to lose track of what's all the stuff that's running on a specific node. So running commands like this will show you, okay, there is actually a lot of pods running on this node, and there is actually a lot of memory consumption, but still wasn't close. So accounting for more magic. So like I said, each of our pods was 2 gigabytes. Use memory for each node that we're talking about. So this node that we're talking about is 902 megabytes, and it says 57%. But 902 is not 57% of 2 gigabytes. It's a 57% of 1.5 gigabytes. Where's 0.5 of our gigabytes? Don't call your lawyers. We're not going to sue DigitalOcean. They're not ripping us off. There's one more thing. So next slide. So there's obviously the 2 gigabytes of RAM that you get for your virtual machine. Each virtual machine in your node pool is the total resources that machine has. That includes everything that you need to run Kubernetes itself. This screenshot, this I took from a blog. This is an example of how on Azure this is distributed. So if you get an 8 gigabytes machine on Azure, you'll have about 100 megabytes used for the operating system itself, because the physical machine itself is going to be running some sort of operating system. Then kubelet. Kubelet is the Kubernetes service that's running on that machine. That's doing all the Kubernetes work, basically. And that takes up a considerable amount of your resources. In this example, it says if you get an 8 gigabyte machine, it takes 1.8 on Azure. This might be outdated, or it might still be the case. But I do know that if you get nodes in a Kubernetes cluster, you do get considerably less than what's advertised. So you can see that the usable memory is pretty low, 5.4 for an 8 gigabyte machine. And we have the same thing. When we looked at the DigitalOcean dashboard, we saw that if we get a 2 gigabyte machine, we get 1 gigabyte of usable memory. And our calculations in the previous slide show that it's about 1.5 that we have. So maybe they under-advertise it. But the lesson that we learned from this is that it's not going to be exactly what you booked. So when you're doing your introspection, when you're doing planning for your resources for your cluster, you have to keep this in mind. And once I learned this, I realized that the true limit of my nodes was actually less than I thought. And the true number of pods running on my node was actually more than I thought. And the stats that I was seeing inside the container were not correct. And once I figured all of this out, it was also Celery that was running in my containers. And I realized I was running with it with a flag of -C8, so a concurrency of 8. So each node of mine was running 8 concurrent Celery processes. On top of that, I mistakenly assumed that those were threads, because threads will use shared memory. Processes will have their own memory. So if you fork a process, it will create a copy. So you basically double the memory at every fork. So in terms of Celery, you have 2 potential fixes. You can either reduce the number of concurrent processes. I had grossly overestimated the available capacity in the pod. So you can reduce the number of processes, or you could also give Celery a flag that tells it to run these workers in a thread. Threads, like I said, don't have a separate memory. The process itself will just book 1 chunk of memory, and that reduces the cost. And the moral of the story, which I'm trying to say, is that once you get an understanding of what's going on inside, you are able to find these fixes. Before this, it was all magic to me, and I couldn't figure out why my pods kept dying. Let's go to the next slide. That's the summary. That's what I just explained. So what's the gist of it? If you're running an application, you can use htop to get an idea of what the processes are on that in a particular container, and which processes, which resources is each process consuming. And you can run kubectl top to get an overview of total resources per node or per pod. And then you have to consider actual versus allocatable resources. Like as we saw before just now, that allocatable resources on this pod is 1.5 gigabytes, not 2 gigabytes. So the same logic will also go to CPU. Your kubelet is probably also consuming some of your CPU, but that's in terms of CPU, it's not going to be consuming a lot. That's my hunch. So yeah, next slide. So what we've learned so far is basically how you can introspect what's going on right now. But in a real life system, that's not enough. Because if your pods die in the middle of the night, you're not there, you don't have a shell access, you're not running a kubectl top all the time. So you need historical data. So you can use a tool like Prometheus. Prometheus is similar to what I just showed you on the DigitalOcean dashboard, which gives you a historical information of what the resource usage has been like for the past 6 hours, past 6 days. Prometheus is a similar tool, which I believe gives you more information. It can drill down to a pod level. So imagine we have historical information of the resources that a pod was using. Another issue is that once, so the OOM killer, like I said, Kubernetes, either you define explicit limits of resources, and if a pod reaches that limit, Kubernetes is going to kill that pod. But in our example, you saw we didn't explicitly define any resources, which will mean that pods use resources as they want, and Kubernetes has its own fixed rules on when to kill them. The defaults are basically if you either have less than 100 megabytes of RAM left on a node, or pod is consuming some percentage of CPU, 90%, I believe, I'm not sure, then it's going to be killed. So if you have limits like this, you will know exactly when it gets killed. And like I said, you can control the damage. You can make sure that your critical pieces of code live, and you can kill things like your asynchronous task processes in case of failure. So yeah, the problem is if the OOM killer kills your pod, you lose all the information. If you don't have the historical data, if you don't have tools like Prometheus, you can't go back and see what the memory usage was at the middle of the night unless you have a tool that's recording that kind of information. So that's the next step. Consider having such a tool, but then just resource usage is not enough. You will also need logging. Real-time monitoring is what we just discussed. This is real-time monitoring, and historical monitoring is Prometheus and that kind of stuff. So you need to combine your knowledge from all these different data sources, information from all these different sources, and that's going to help you find out issues in production systems. For example, if I see in historical data that there is a peak of CPU usage at midnight every day, that tells me that, okay, maybe there's something happening at midnight. We need to limit its impact. But then you would need logging in order to know actually what was happening at midnight. So some words about logging. Logging is the same as, has the same problem. If your pod dies, you lose all the logs for that pod. So what do? You have some external tool which collects logs and aggregates them and allows you to query them and filter them, dig deeper into them to find what was happening at a specific time. So if you have a log aggregator, for example, Logstash and Kibana, and then you have Prometheus, then you have the full picture. Then you can see, okay, there was a peak at a specific time, and the logs show that at that time, hey, we're sending out marketing emails at that time every day, and that's why the CPU usage goes up, for example, So you need a bunch of different systems in production systems that need to have a high uptime or high reliability. But what happens if you've identified the problem to a specific pod, a specific service inside a pod, but you don't know how to proceed? Then that's one level deeper. Then you've identified the piece of code, and you need to profile it and do load testing. What that means is, for Python, there are tools like PyFlame. For other applications, there is also tools for profiling the code. Profiling basically means running your code and collecting data on which parts of the code are consuming which percentage of your time. So profiling and load testing sometimes go hand in hand. So you can have a script that generates load, and you have a code that's running that you profile. So then you can see, oh, there's one specific function that's taking 80% of my time, and then you could optimize stuff like that. So this slide contains a lot of information. This is all the next step, how you proceed from here. I just wanted to give you guys a picture of how this knowledge, how this information connects to working with production grade systems. And yeah, that's about the end. Learnings. There's a fixed cost per node, as we saw. Maybe if you get larger nodes, it's easier to manage your resources because first of all, your OS and kubelet are always going to take the same cost. And like we saw, all those extra services, well, they're going to take the resources anyways. But with larger nodes, as an added advantage, it allows you to schedule services with different resource requirements easily. So what as an example, if all of your nodes have only 1.5 gigabytes of RAM available, but all of your pods use 1 gigabyte of RAM, then there's nothing you can schedule in that missing 0.5. But if you have 6 pods of 1.5 gigabytes each, it's probably better to have 3 pods with 3 gigabytes each because there's more room to pack those resources. Second learning is be aware of these commands, htop, top, free. When you run them inside the container, they don't report correct stats. Manage resource limits to take control when resource starvation happens. So controlled chaos, controlled degradation. And then the last one is what I explained. If you need historical metrics, consider such a tool and consider using log aggregators. So I hope I've inspired some of you to learn more about this kind of stuff and try out these things on your own. If you have a job where you work with Kubernetes, try out these things. But if not, try it out on a Minikube. And hopefully this has been useful.
Okay, thank you.
Thank you
to both of you. We're in a short evaluation form. So the participants want to fill it out, we are very happy for your answers. And I will post it in YouTube as well.
If anyone has any technical questions as well, I'm still here. You can go ahead and ask those as well. But Sahil has some sys too.
Yep. Thank you, Furqan. Yeah, that was a long presentation from Furqan. Yeah, thank you very much. I was kind of worried in the middle, like that it was going too technical, but overall, the type of questions that we were getting, I believe that people were getting it and they were understanding what we were trying to say, and summarized it very well. So thank you, everyone. And just a short thing, like if you want to know more about Motius, if you want to know more about what we are doing, and if you want to join our talent pool, you can just open this URL, go there, apply, see if you like something, and yep, get in touch with us. Okay. We have a question here, Furqan. Is there any limit on number of pods to be run on a node?
Yes, there is a limit. In my case, it is enforced by the cloud provider, DigitalOcean. I believe it is 1,000 pods per node. When you deploy your own cluster, this is part of the cluster configuration. You can configure that limit. I'm not sure if you get it from a cloud provider that you can change it. I'm not sure about that. I believe it's a hard limit set by the cloud provider. But if you set up your own, you can change it.
Cool. Then that's it from our side. Dhruv.
Thank you, guys. Thank you for being such patient listeners. I hope you guys enjoyed.
Great event. And hopefully we see you again.
Yep. Same here. Bye.
Hopefully.
Goodbye. Have a nice
Bye.
evening.
Take care.
Or
Enjoy your evening.
afternoon. Goodbye.
March!